Even though it is stated that fleche, turbidite, these terms are to be avoided in formally naming the lithostratigraphic unit, let us take an Indian example. I am going to present the stratigraphic succession of the Tethyan zone, the Indus zone and the Ladakh batholith. Here is the map. In this part of India, Jammu Kashmir region, the rivers are shown, for example, the Indus river, the Zanskar river, and here is the geological map showing the lithological units. Once we look at the Indus zone succession, there is a reference of the term fleche, Nindam fleche, then Lamayuru fleche, Jurutse fleche, red molas term has been used, the Rumbak molas, the Zinchon molas. The fleche and molas deposits are presented here. This is the molas deposit and this dotted region is the fleche deposit. Once we look at the Tethyan zone succession, we find Kangi La fleche. These are the edges in the succession. So, I repeat, even though it is asked not to use the term fleche in the stratigraphic lithostratigraphic units or in the succession, sometimes geologists have used them, looks unavoidable in the succession. We need to avoid a few more terms in the lithostratigraphy ideally. Dike, the other spelling is DIK, dike, stock, pluton, batholith, intrusive, etc. There can be suitable terms such as soot, supersoot and lithodem. How to change the rank? Suppose there is a stratigraphic nomenclature X formation and we want to convert this formation into X group, which means what was earlier marked as X formation, within that we are interested to mark other formation. Therefore, formation is elevated to groups. In that case, we do not discard the geographic term X. It remained as it is, only the rank changes. That is what is stated, X is not changed and X can be a geographic location. However, note that in case you are interested to change the X formation into Y formation, that means the geographic location itself is to be changed. If it is so, then of course avoid X word in the lithostratigraphy. So, that provision is there. We are now going to see a few terms in stratigraphy such as infra. Infra means below. If I say infra X, this means there is a lithological unit X and below that lies infra X. So, if I say infra Cambrian, that means rocks below Cambrian. So, I can write and below that will lie infra Cambrian. As per the geological time scale, below Cambrian lies Archean and Proterozoic rocks. So, to represent the Proterozoic rock, one way is to call as the infracambrian. Infracambrian rocks are older in age than that of the Cambrian rocks. We are going to see the use of infra term in Indian stratigraphy. Let us look at the Neoproterozoic stratigraphy of a part of Indian Lesser Himalaya. A few well known locations in the map: Dehradun, Rishikesh, Nainital, Mussoorie. In this map, the Kroll syncline is presented here. The Kroll group of rocks crops out. such as Crole A, Crole B, Crole C, Crole D and Crole E. Interestingly, below Crole A or below Crole lies the infracrole formation. I wanted to emphasize an Indian example of use of the term infra. So, infracrole is an example coming from the Indian Lesser Himalaya, which is a part of the west, and in this case this is in western Himalaya in Uttarakhand state. In this connection, I want to talk more about the Crole unit. Here almost the same map, and the Crole unit here called as Crole group. What is the age? Neoproterozoic to early Cambrian. Interestingly, note the different formation names within it. Look at the succession Crole group. The formation names are Crole A, Crole B, Crole C, Crole D and then Crole E. Crole group has been divided into A, B, C, D, E formation. Ideally, this should not be the nomenclature A, B, C, D, E, but it has been done in the Himalayan context. And again, below the Crole unit, we find the infracrole formation. And while a significant part of the Crole group is carbonates, depending on actual rock types, the formation are divided, and also along with rock types, colors of rocks also used to classify A, B, C up to E units. The different formation of their portions can be of similar chemistry. Now, we will see the term supra in Indian stratigraphy. If I say supra X, this means that there is a layer X and over that lies supra X. This is the meaning of the term supra. Let us take an example from Gondwana rocks from the Raniganj basin from eastern India. That is Indian map. This is the study area, Raniganj basin. Here we are going to look at first where is the Panchet formation. This is the location, one of the locations where the Panchet formation is exposed. The others are here and over there, also here. As per the stratigraphic succession, the Panchet formation is of early Triassic age. Now, interestingly comes the term supra Panchet, and here is the use of the term supra. In the stratigraphic succession, supra Panchet lies above the Panchet and its age is late Triassic. This is one of the exposures of supra Panchet rocks. Let us look at the tsunami deposits and how far stratigraphic correlations can be made from such deposits. Tsunami deposits can be defined as sedimentary layers deposited over a low-lying coast by a tsunami. This tsunami, as we know, can be produced by either an earthquake or a submarine landslide. We are not getting into it. We were interested to see the deposition and how far stratigraphy can be established. What are the components of the tsunami deposits? They are usually well sorted sand particles. Well sorted means grains of nearly the same size or radius. They extend inland for several kilometers across the coastal lowlands, and sheets of gravels, pebbles, and there can be boulders, giant boulders of almost 30-meter diameter may be present. However, such giant boulders have been debated for its origin. Usually within around 50 meter, that means very locally, that is what is said local, gross correlation of tsunami deposit is possible. We will see how it can be made. So, for large distance over kilometers, we will not be able to correlate layers, but within say around 50, within say 50 meter, gross correlation is possible. Say this is the basement and over which tsunami deposits have been noted. This is the idealized diagram. These tsunami deposits can have internal layers, and the upper boundary of these deposits, that means this layer and that layer, are usually mud caps. Mud is deposited. When the tsunami has stopped, the water has been tranquil, mud gets deposited at the top. It can contain entrained materials, which means materials coming from other sources. Therefore, if I date these mud cap material, I will not get the age of tsunami. I will get ages older than the tsunami deposits. This is a problem in that case. Mud caps can be difficult to distinguish from subsequent mud deposition. The mud caps can be followed by much later another set of mud deposition. So, distinguishing these two mud layers can become difficult. So, what is the option with us? We may go for non-destructive techniques to find out the true stratigraphic components. What are the non-destructive techniques? Computer tomography, CT and XRF, X-ray fluorescence can be useful to find out to correlate the tsunami deposits. The moment we say that dating will be used, that means it is going outside the scope of lithostratigraphy, rather chronostratigraphy comes into picture, and on chronostratigraphy I am going to have separate lectures. The OSL technique can be useful, which is the full form of OSL is optically stimulated luminescence. Such dating done on the sediments can give the burial age of the sediment. Now, this becomes important when these sediments got buried, and it is advantageous in the tsunami deposit studies. So, mud caps can be problematic, but the tsunami deposits, avoiding the mud caps, can be attempted for the OSL dating. Suppose the tsunami has brought the deposit, we can have a bottom layer, the sediments, that means the pre-tsunami deposits, and the top layer, which can be the post-tsunami deposit. If we find the burial age of the post-tsunami deposit and the pre-tsunami deposit, then we can bracket the timing of tsunami deposition. Now, the dating of the top and the bottom layer can be done by 14C dating. At the same time, be careful, 14C data can give the maximum age, or even the uranium thorium dating can give the maximum age. So, they may not be useful. Let us have a look at the tsunami deposit in terms of ideal diagram. This is a pre-tsunami deposit, tsunami has not come, and in the coastal area this is the existing deposit. This symbol indicates the terrestrial organisms which are present in the sediment, and then with time this is the progressive younging. Now, the tsunami has come and this part of the material got reworked, and you can see the level has come over there. Now, within this deposition again the terrestrial organisms will come along with the water. Now, the deposition has taken place, this surface has become wavy and quite water condition, and then finer sediments have come. Again here we are getting the terrestrial organisms. So, the terrestrial organisms are present in pre-tsunami deposits, in the tsunami deposits. Now, in the post-tsunami deposit also we are getting the organisms, terrestrial organisms. Now, the terrestrial organisms here, here and here on the sediments, they keep reworking the sediments locally, and this can disturb the boundaries shown over here. So, we may not get such sharp boundary for the tsunami deposits. Let us see the term cyclothem. Cyclothems are cyclic or rhythmic sequence of sedimentary rocks. So, it is not a single rock type, sandstone, limestone or siltstone, rather there will be cyclic or rhythmic alteration of more than one sedimentary rocks. Cyclothem deals with sedimentary rocks. In few cases, cyclothems can be recognized by the geographic names. For example, I can say X cyclothem may use as a stratigraphic unit. However, such naming is informal. It is not a formal way of writing. In the formal lithostratigraphic scheme, we will not encounter such a thing. In more detail, cyclothems are alternate marine and non-marine depositional conditions in low accommodation and low sediment supply. They are related to sea level change. So, the Eustace word is coming here, and or the glacial cycles. It is important to tell that there is no unique succession produced in the cyclothem. We cannot say that sandstone siltstone alteration is the only cyclothem possible worldwide. We are finding the cyclothems from the late Paleozoic successions with conglomerates brachia facies in the base. Students to remember, in the late Paleozoic succession we usually get conglomerate brachia facies in the base. Brachia means crushed rock. Brachias can be produced by faulting, brachias can also be produced by other mechanisms. In this case, there is no guarantee that this brachia is indicating a faulting. They are well found in the Carboniferous rocks. Cyclothems are found, I repeat, in the late Paleozoic succession and also in the Carboniferous rocks. It does not mean that these are the only two places in geological time scale, but these are the two well studied places. Distinct cyclothems can be traced hundreds of kilometers. This traced means we are talking about correlation. A gross correlation at least is possible. Complete cyclothems are few meter thick, important. We are not talking about a cyclothem whose total thickness is 3 centimeter. They are usually few meter thick. Mainly they are found in the low gradient epicontinental shelves. Epicontinental shelves are shallow seas that floods interior of continent, often associated with periods of high sea level. Sequence stratigraphy is applied on cyclothem. We are going to have separate lectures on sequence stratigraphy. Those concepts apply here on studying the cyclothems. Let us take an example of cyclothem from eastern India. We are going to see the subsurface, that means below the ground surface, the Borakar stratigraphy. The Borakar rocks are of the age of early Permian and is a part of Gondwana stratigraphy. Specifically, we are going to see the Bellampalli coal field from the borehole logs. Here is the Bellampalli area and the coal fields. This is the Bellampalli area. Note that this is the Indian east coast and the surrounding areas. This is the Indian east coast, that is the Bay of Bengal for the international viewers I am referring. That is a well known place, Chennai, but far away from the Bellampalli area is here, Hyderabad. We are talking about this location. The detailed stratigraphy is provided in terms of 3 stratigraphic successions established from the borehole logs. We will try to understand cyclothem. Note the symbols: sandstone, these are the sandstone units, shale, thinner units, and there are others, and then the coal units. Now, from bottom towards top, let us see, it is sandstone, coal, sandstone, then there is shale, then there is coal, then there is sandstone, and we see a rhythmic alteration from bottom towards top. The same thing can be found in this well and from this well also. So, this is the example of cyclothem. We may not find this kind of repetition perfectly. We can find out repeated environmental conditions. For example, from bottom towards top, based on this lithostratigraphic column along with some biostratigraphic information, we are finding transgression which repeats. We are finding the offshore marine environment, and the situation repeats with time, and this is common in many places in the world. In coastal area particularly, cyclothems can be deciphered. Here is a detail of cyclothems. This part I will leave to watch. Look at the lithologies and then see how the cyclic variation has been found. Deciphering cyclothems from drill cores needs some caution. Consider two rocks A and B got neutral folded or recumbent folded, that means they got folded sidewise, and a vertical drilling is now made. We come across rocks A, B and A. Now, this repetition is not due to change in deposition from A to B and then B to A. Rather, the repetition comes due to tectonic deformation. This means just by noting in the drill core that there is a repetition of units A, B and A will not guarantee that we are dealing with cyclothem. Consider a reverse fault. This is the fault plane. If I am standing on the fault plane, my foot lies on the footwall block and the other block is called the hanging wall block. Litho units A, B and C are considered. Hanging wall block has gone up relative to the footwall block. Now, a drilling has been made. We come across rocks A, B and then A and B again. If I consider up to this much of drilling A, B and A, B. Here this repetition is not due to folding, but due to reverse faulting. So, this one also is a tectonic deformation. Let us take a case of a low angle normal fault. This is the low angle normal fault that slipped inclined lithological contacts. Lithology A, B, C and D are inclined to the right hand side, and also noting the displacement, one can assign the half arrows and it is a normal fault. If one is standing on the fault, then the foot lies on the footwall block, the other block is called the hanging wall block. As we see from the half arrows, the hanging wall block has gone down relative to the footwall block, so it is a normal fault. Now, a vertical drilling has been made. What are the rocks we will encounter? A, B, C and D. So, A, B, C and D, and then repetition happens A, B, C and D, A, B, C and D. So, in case of a low angle normal fault that slipped inclined lithological contact and a vertical drilling performed, within the drill core we find a repetition of units. This too is an example of repetition of litho units observed in the drill core due to tectonics. While defining the term formation, we have talked about lithic heterogeneity and lithic homogeneity. An example of heterogeneous rock unit deserves a mention here. The term is melange. It contains blocks typically of hard and competent lithologies, supported and surrounded by fine-grained matrix of shale, slate, serpentinite, etc. Melange can be found in tectonically deformed areas. So, the tectonic fabrics can be developed, but it may or may not be present. Melanges devoid of tectonic fabric may indicate debris flow. Landslide may happen. Rocks as pieces come and they get mixed up haphazardly, producing a melange. So, sedimentary process can also be responsible. So, the two processes I can think, one is tectonic. What it can be due to faulting or diaparism, or I can write a sedimentary process. In the sedimentary process, notably landslide. When we use the term melange, it has to be a unit that is mappable at 1:25,000 scale or 1:24,000 scale. Note that the scale that are referred here are different from that for the definition of formation. Let me write down. The scale referred here differs from that of definition of formation.